So the next speaker is Ronald from Observos. Sorry, Observos. And Ronald was again one of our first people to join us. Ask for people. You got it? Okay, cool. Give a second before you search through. That's fine. Okay, there you go. Perfect. Great. It's amazing. The little Chromebook has got more resolution than my laptop. So again, thank you guys. If there are people who are looking to speak or present, just drop me a line via the meetup group or come and see me after this talk and let me know as well. Okay, Ronald.
Thank you, Serge. All right, so we're going to show a really brief video on what we see is our take on the concept of the Internet of Places. A little bit of a variant on the Internet of Things, but extremely similar.
Wide Web on a daily basis. It inescapably pervades our lives, but the web isn't the only aspect of the Internet. The Internet is a noun. As such, it can refer to a person, place, or thing. In this case, all three. We make use of the Internet of people every day. It's an important part of how we now interact with our work, family, and world. We spend much of our day connected to other people through the Internet. Email, social networking, news outlets, and financial websites seem to follow us everywhere. There's an emerging Internet of Things, which has the potential to revolutionize what we own. Smart toasters, light bulbs, dishwashers, and cars all network together with vastly improved usability. Archives of 3D objects waiting to be printed for the cost of the materials they are made from are the future for consumable items. But what about the Internet of Places? Sure, we have access to information about locations through weather websites with all sorts of detailed measurements. The problem with those are that they're typically one-directional, and unless you have some expensive equipment, all you can do is watch the show. But that is what television is for. This is the Internet, and it demands a free flow of information in both directions. In steps Observos, the Internet-connected environment. This system aims to complete the loop by bringing the Internet of Places to the individual. First, as wirelessly networked ambient sensors for temperature, humidity, and air pressure. However, in the future, Observos will provide a comprehensive sensing control network for every aspect of your surroundings, allowing the user to record, publish, and act upon that information. From any point on the Internet, Observos extends your awareness of environments which interest you. If this sounds exciting, then continue to watch while we change the way the game is played.
This is Loren Loren, and we're the co-founders of Hexagonal Research Corporation, and our inaugural product is Observos. Tonight we're going to share with you a little bit about what our vision is for the Internet of Places and what our process has been so far in developing it. In 2001, I was an assistant manager for Sherry's Restaurants, and as a manager, I had to take hourly temps of all the food stored in our restaurant. The walk-in freezer, walk-in cooler, the reach-in coolers, the soups, everything. But I'm a geek, so handwritten logs taken from analog sensor measurements really just weren't good enough. I looked for a digital solution, but there really wasn't any to be found. And so, like a good maker, I decided to make my own. So Loren and I began discussing the designs for an automated system that monitored our environments. However, between work, marriage, college, having a son, our project was really relegated to the back burner. Fast forward to 2011, and we we dusted off our idea and decided to pursue it. You can see some pictures behind us from our booth at Engadget Expand, where we were competitors in their insert coin competition and some of the prototyping that we did in this process. Observos, our idea developed into the product we're now calling Observos. Observos is designed to be a comprehensive sensing control platform. So in the restaurant, Observos can automatically generate an accurate hourly log of every area that it monitors, saving on labor and potentially saving on food waste. If an area is not monitored, that can be logged for how long it's in an exception state, if you want to put it that way, as long as there's a warning. Observos doesn't really stop there, however. It's not really limited to restaurants. While we were developing the system, we found several other areas where it could be applied. We have been working with a local nursery that has 600 acres of greenhouses, and the goal is to have one sensor in each greenhouse, each mesh networked back to the base station in the office. From the base station in the office, all the conditions from each of the greenhouses is being reported. The information is then uploaded to our server and made available via the client's dashboard on their smartphone, tablet, or computer. So you can see live data right now. This is actually at one of our sites, and that's the dashboard with all the sensor data that's being collected. From the dashboard in the office, conditions inside each greenhouse can be monitored, complete with historical graphs and reports in real time. You can bring it up. That was a little bit easier to see, but so this is one of the graphs from one of the sensors that we are using right now. Lauren will bring up the dashboard in a second.
And
I'm standing in the way. So that's the dashboard currently. This is actually the demo that we used at Engadget Expand. So that's why it says Engadget Expand and Observos booth. All right, so from the dashboard in the office, conditions inside each greenhouse can be monitored, complete with the graphs and reports in real time. Alerts to problems inside each of the houses that you have predefined rules set for will trigger an email or text message alert to be emailed automatically to the individuals responsible for specific areas of that nursery. On a smaller scale, a week ago on Monday, we launched our Kickstarter campaign, which we have brochures up scattered around here, for a consumer version of the Observos platform. So Observos, can manage anything that you want. If you have an area of something that's important to you, it can monitor that. If you have a humidor or wine cellar, Observos can email you if the humidity drops too low. If you have a personal or community greenhouse or hydroponic setup, Observos can send you a text message if the temperature is getting too high. So our development process began where many other projects like ours began with a humble Arduino. This is Arduino Uno, and stacked on top of the Arduino board, we added the Ethernet shield so that the sensor can go online. We added a wireless XP shield so it can talk to other sensors. And then we built a sensor shield on top of that so the device itself can be made aware of its surroundings.
And it also includes an SD card so it can do extended logging in the period of absent internet.
Yep. Based on what we learned from building our first simple prototypes built around Arduino, we next embarked on designing our first circuit board from start to finish. That was an incredible learning experience. And as you saw back there, some of the other people giving talks, it's definitely a challenge. I'd recommend anyone who's interested in tech to try it and just learn how painful it is. That validates the pain we went through. So after hand assembling our first 3 prototypes from those boards, there were some pictures earlier you saw of them. So we are at a point where we had similar functionality to the Uno, but it was about half the cost because we had assembled it ourselves. And it was far more reliable. Plus, it had a screen and it lit up pretty. From what we learned from those first 3 prototypes, we did another run of another revision. Building on the Pinocchio project's open source hardware designs, we had 15 prototypes built that were, again, less expensive than our previous revision, and they were more elegant than the previous design. That is this board. So this board does a substantial portion of what the original Uno did, but at a fraction of the size and the cost for us. Even having these boards built for us and assembled, and having someone machine an enclosure, and including the LCD, it's still cheaper than the Uno and all of the add-on modules. So if you're doing hardware iterations, Arduino is a really excellent place to get started and to test things by, jumper wire and plugging stuff in and unplugging stuff without really that much cost and changes. But once you really want to test something that isn't going to be changing as frequently, doing a board on, these were actually the purple PCBs, the giveaway, these are done through OSH Park, which was mentioned in the first presentation, which is done by Dorkbot's Land. And they're really inexpensive boards to have done. They were stuffed locally. Our first ones we did ourselves. Next 15, we weren't about to do that. These are all very small components and leadless. So we had the 15 prototypes built, and those arrived just in time for us to leave for San Francisco to go to Engadget Expand. And we had some headache and trouble, and we programmed them all up, and none of them worked. And they didn't work because the barometric pressure sensor was attached in reverse by the board assembler. So the day before we left, we drove out to Tigard, had the board assembler, they fixed it for us. They were really, really great about customer service, which is something I can't say for Sunstone. I don't know if they would have made the same mistake, but had they, we would not have had prototypes for taking to San Francisco.
Can you tell us who the board assembler was? Just out of interest.
Yeah, it's SMT Northwest.
SMT Northwest.
Yeah. And they're local, they do a really great job, they're extremely approachable.
Just right in Bridgeport.
Yeah.
The other thing we also had with this is, apparently there's some power supply issues that had still been, were working out by the original designers of this board. And I was submitting him my data of what I was detecting. At the same time, he was working on fixing that same problem. And so we discovered one design flaw with this. You have to have a battery or it won't power up correctly.
So yeah. So we had a local CNC shop build us our enclosures based on kind of what we were designing around for the future, which allowed us to iterate a lot faster than sending something off to Shapeways and having it 3D printed, come back, and maybe not even work. So designing local is really a great way to ensure that everything's going to come together in a way that's beneficial to you. And then in the future, you can work on, finding and sourcing lower cost and larger runs solutions to your problems. So we went to Engadget Expand. We competed in their Insert Coin New Challengers competition, and we did not win. It was a great experience, and you may have seen our little thing on the Dorkbot or the Internet of Things Meetup mailing list, asking everyone to vote for us for Expand. However, there was an aquatic robot there, and none of the other competitors stood a chance. So of the 10 of us, the aquatic robot took home more votes than number 2 and number 3 and maybe number 4 combined. But what can you do? We made a lot of great contacts there. We had an amazing time doing our first trade show as a company. And it really has felt a lot like a project up until now. And that was the first moment it really felt like a company.
AWOL was very good about sponsoring this and giving us pretty much a free ride almost.
Yeah, AOL gave us a travel stipend to go down there. They paid for our booth and meals while we were down there. So it was a very cost-effective experiment as well. So, yeah, we had all our prototypes set up. We did our booth. We got to make a lot of great contacts. We came back, and that Monday in the car on the way back home, we launched our Kickstarter campaign, and it wouldn't, and then it flattened out. So we're currently in our second week of our Kickstarter campaign. This is a week ago Monday, and we're about $1,700. So that's another experiment. We're going to see just how well we win or lose. Either way, we're going to learn a lot from it, and we're going to continue working on the project with our commercial partners. But if you are interested, you can grab one of those flyers on the website URL on them. We'll take you to our Kickstarter campaign. And so you can get an Arduino compatible board. Right now we have a early bird special that's $50. After that, they're $75. But these have an 802.15.4 radio built into them. So it's basically an XP and an Arduino. It also has the temperature, humidity, air pressure sensor, 2 RGB LEDs, so they're really pretty. And It has 256K of flash, which is like 12 and a half times what the Arduino Uno has. As far as storage space, it really can't be beat. And as far as cost, ends up being a lot cheaper of a prototyping board than an Arduino would be. If you're trying to build something wireless and a turnkey solution isn't what you're looking for, these are built around a really great processor we listed on our website. And
responds to an incoming email, then you can respond to that for our first revision. Beyond that, I am looking at just making a simple API on the website so that you can pull information and pull alerts. And when I get that more complete, I'm going to look at maybe talking to if this then that, if you've ever heard that website. And they can even pull from our API and then respond to it various ways too, like linking an LED or, I mean, a lot of other things to it. I mean,
do things.
Well, doing something else somewhere else. Question.
Yeah.
I may have missed it. What's the connectivity? Is it Ethernet or Wi-Fi?
So the base station plugs into your router over Ethernet, and then these are using a meshing. These are currently using what's called the Atmel lightweight mesh. We may be using Zigbee in the future, so we get a more robust mesh that can work with existing sensors on the market. But we haven't nailed down exactly which technology, but it is meshing. So if you can go 100 feet or 400 feet between the sensor and the base station, if you add another sensor, it can go an additional distance. And that's the way we're able to span from greenhouse to greenhouse across the 600-acre nursery. So each one passes the messages back to the base station inside the office.
Do these connect with each other?
Yes, they all talk to each other.
And then one is designated as a base station?
Correct. And we have been playing with Wi-Fi. That's actually what this one is right now. We're using the Wi-Fi on this one, but the product itself is going to be Ethernet-based.
What about cellular? What about mobile device?
These can be, like this is wireless right now, so they could be mobile, and they're also going to be a lot smaller. Because they measure ambient sensors, the utility of it being mobile might be limited. If it was like a contact-based, like a heart rate monitor or something, then I could see it being of more use. The versions without the display get about, hopefully, 6 months is the target for battery life on 3 AA's. So it will be a little bit bulkier because it takes 3 AA's. But yes, it could be mobile. And if this, like I said, if this isn't what you wanted, a prototyping board that has it built in, this could be much easier made mobile